today's lesson, we will be looking at the assignment questions for lesson 4. The previous lesson, we looked at characteristics of a linear function, and we looked at the leading coefficient, the slope, and the behavior, y-intercept, x-intercept, domain, and range. Today, we will look at your assignment questions and use the knowledge about these concepts to answer those questions. Okay, let's go on to it. And this is so there are 8 questions here. And for these questions, you'll need your graphing technology. You'll need Desmos or TI-83 calculators. Okay, I'll just make that home screen blank here. Also, it would be a good advice for those of you who are using the graphing calculator to zoom out a little bit here, to have with you this handout, how to use a calculator. This would come in handy. Or if you're using Desmos, this handout here. Okay. So things you'll need today are your booklet, and we're looking at page 23 in your booklet. You also need your calculator or phone with Desmos and the TI-83. Okay, let's go to the first set of questions. So recall, whenever we are looking at any equation, the characteristics of an equation is that if it's written in any form, just to look at it's y, this will be your coefficient. That's your y-intercept. The sign in front of it refers to your sign, which is be a positive or a negative. So let's look back at one of the examples we did. Here we have y is equal to negative 3x plus 5. And you're asked to sketch this function. First thing you do, you go to your calculator and our Desmos, and you enter this equation into your calculator to get your linear regression. You sketch it, and the interpretation is that they'll ask you for the end behavior. End behavior refers to the quadrants. So recall, when we label in the quadrants, the first quadrant, x is positive, the y is positive, is quadrant 1. And we go counterclockwise, quadrant 2, quadrant 3, and quadrant 4. The y-intercept would be referred to the b in the equation. The slope refers to the leading coefficient. And the sign of it refers to the direction of the graph. So for this one here, the slope direction is decreasing. So if you have a negative slope indicates that the slope is decreasing. And decreasing, you mean as you increase your x, the y decreases. And anytime you have a negative slope, the end behavior is from quadrant 2 to quadrant 4. If the slope is positive, then the end behavior is from quadrant 3 to quadrant 1. So be careful how you label your end behavior. The domain refers to the values on the x-axis where this graph is valid. And in this case here, this graph goes to the left to infinity and to the right to infinity. So we can say this graph is going from negative infinity to positive infinity, or you can write it in this way, x such as x is an element of real numbers. So any real number will satisfy the domain. The range refers to y values where this graph is valid. And it goes up to infinity and goes down to negative infinity. So we set the graph as from negative infinity to positive infinity. Notice whenever they are infinity, the bracket is not a square bracket. It's a smooth curve. It's a curve bracket. So be careful. This is called interval notation, form of writing. This is the set notation. So let's review. Your leading coefficient is a number in front of the x, or the slope. The sign in front of it will give you the direction. If it's negative, is decreasing. If it's positive, is increasing. And if it's positive, going from quadrant 3 to quadrant 1. And if it's decreasing, from quadrant 2 to quadrant 4. So just review those. And generally speaking, you can tell from the sign what quadrants is on. What we will do is we'll input the equation into our calculator to verify our knowledge of it. So let's look at the first one. Here we look at y is equal to 3.7x plus 1.2. Now, the sign of a leading coefficient here is positive. Generally, a positive is not indicated by convention. So we can say this is positive here. Now the slope direction, as I mentioned, it's going upwards or in a positive direction. Well, let's verify it using our calculator. Now, let's just zoom out here a little so you can see. Okay, just want to center my video here. Okay. So recall, if you're using the graphing calculator, you may want to refer to your instruction sheet if you, and I'm referring to instruction sheet here. So we want to input into our calculator y is equal to 3.7 x plus 1.2. We'll ignore all of these. We just want to enter into our window here. Okay, so we press the Y equal button. So anytime you're entering any y in equation, we press the Y equal button. So just refer that just to remind you if you've forgotten. So whenever you're entering any equation into your calculator, you press your Y equal button. Graphing calculator. With Desmos, it's a bit more straightforward. Once you open up Desmos, you go straight to this cell here, this box here, and you'll just tap on it. And now you enter exactly what you see. The question here is y, and it's a little bit tiny. Y is equal to 3.7 x. graph comes up right away, plus 1.2. So that's my graph, make sure it's fine. Now I can see there's 2 arrows here. If I touch that 2 arrow, it will go down, that's my graph. Then I can use my fingers to pinch it. So this is my graph, it's going from quadrant 3 to quadrant 1. That's the end behavior. Now I can find the y-intercept easily by tap on it here. It's my y-intercept and that's my x-intercept. The next lesson we will be asked to find the y-intercept and the x-intercept. So from Desmos, the slope direction, it's from quadrant, it's going up. So the slope direction is going up, or you can say it's going up, or increasing. You can say it's increasing. So it's going up. The end behavior is from quadrant 3, Roman numeral 3, to quadrant 4. Let's look how it appears in the graphing calculator. Which is on. Okay. So for 3.7x, now this is your x. Okay. Now it's a plus button here, 1.2. Next, we have to press the graph button. Now my graph looks slightly different. That's because I didn't reset my calculator. But you don't have to go reset your calculator. You can change the window on your screen by going to Zoom and press 6. Get you standard. And that will give you a window goes from negative 10x to positive 10 to negative 10 from your y. So now you can see it's going from quadrant 3 to quadrant 1. That's your end behavior. Okay, let's go on to the next one. Here we have 4x minus 5. So the leading coefficient here is positive. So we can write that here. The slope direction, we are just going to enter into our, so let me make this up. Now, one thing notice I see no keypad here. Right. I can touch these 2 arrows here and then go back to the keypad. Now, with Desmos, you can touch this one and it will be off. It should be off. You can leave it there. Nothing wrong with it. But if you touch it again, it reappears. Now you can delete it, or you can go to the next line and tap it and hide that one. And now input the new equation, which is y. Let's see here. Which is y is equal to 4x minus 5. So we'll tap in here, we put y equals 4x minus 5. We got exactly then, I'll tap it here. And we can actually zoom in a little bit here to see, this is my x-axis, this is my y-axis. So this is positive going from quadrant 3 to quadrant 1. Let's look at our graphing calculator. from our graphing calculator, we can go back into the equation here. You need to get rid of that equation or else it will show up. There's no way of hiding it in the graphing calculator. That's what you did in Desmos. So in your graphing calculator, I'll put exactly what I see there for, this is your X button, plus -5, -5. Notice this is your y-intercept -5. So as you can see from Desmos, the y-intercept is -5. X is 0, y is -5. Now I press my graph button, and notice this line crosses the y-axis at -5. So we have our graph is increasing or going up, and it's from quadrant 3 to quadrant 1. Quadrant 3 to quadrant 1. Let's write it. So slope is up or increasing. Or up. And the end behavior is from quadrant 3 to quadrant 1. Oops. This one I have a quadrant 4. It should be wrong. It's not quadrant 4. It's quadrant 1. Oops. Okay, sorry about that. Next, let's go on to the next. So here we have y is negative. Now you have an open bracket x plus 3.7. Now you can simplify this, or you can leave it as it is exactly there and enter into your calculator. But I'll leave it like that for now, then I'll show you how to simplify it. First of all, our leading coefficient is negative. Right. But sometimes it can be misleading because you may have a negative in here and you end up with a positive. But generally speaking, you have just one sign. Now, if it's negative, so the sign of a leading coefficient is negative. You can put here negative. The slope direction now, we know if it's negative from our knowledge in the past. If it's negative, it's going down and it's going from quadrant 2 to quadrant 4. But let's prove that. Okay, my Desmos. Got the graphing calculator. Now I'll move this up so you can see the equation. So this is my equation I'm working with here. Make sure you can see it. Okay, there we go. And I'll have my Desmos beside me. So let's go to graphic calculator first. I'm going to go into y equal button, clear that. Negative. Now, I'm going to move this a little bit here so you can see. Be careful when you're using negative. It's not a subtract sign here. The sign in front, what we're using is this negative button here. The one in the bracket at the lower end of your calculator. Just be to the left of the enter key. So we press that first to get our negative 2, and this is your bracket here. It's to the left of the division sign. It's an open bracket, x plus 3.7, close bracket. Now you press graph. So what we suspected is from quadrant 2 to quadrant 4, it's going down, it's decreasing. Okay, so let's go to Desmos, and I can hide that one. And I can go to the next cell. Notice I'm not removing any of my equation, but you could. You can. I can go back and so it's good to practice equals negative. Now in Desmos, it doesn't matter if you're using subtract sign or the negative sign. It recognizes it. Open bracket. Oh no, I didn't put my 2 there. So put 2, negative 2, open bracket, x plus 3.7. Then you can close the bracket. Okay, now you can see any graph, right? To see a graph, you press the plus button. Oops, there we go. Now, I just want to show me my graph. Okay, we are now. Did I put in the wrong number? Oh yes, I did. 3.7. I wonder why. 3.7. Come on, there we go. So hide that. Here I didn't put the right values in there. I have 37. If you don't put in the values as given, you end up with a really interesting graph. There I had 37. So the graph is way above here, way in somewhere above the calculator. So now it's very similar to what we have. Okay, so I can make this similar to like, now notice that's your y-intercept here. It's just, and notice you cannot read out the y-intercept as 3.7 from, because it is not written in the standard y equal mx plus b. Now, if we look at this here, the y-intercept, remember y equal trace and x equals 0. The y-intercept is negative 7.4. Let's see on Desmos, what is it? Negative 7.4. So we have the exact values for on Desmos and the TI-84 for the y-intercept. So how is that different from what you see here? And the reason for that is that you have a factor of negative 2. So negative 2 times 3.7 is negative 7.4. So if you were to simplify this, it would be y negative 2. Zoom in here a little bit here. So you have negative 2 times x will give me negative 2x. Negative 2 times 3.7 will give me negative 7.4. And that's where the 7.4, negative 7.4. So once you simplify this, you can read it off now. Your slope is negative 2. Your y-intercept is negative 7.4. So that's why in your calculator you see it's negative 7.4 because you have a factor of negative 2. So the slope direction, quadrant 2 to quadrant 4. That's sorry. Slope direction is it's down or negative or is decreasing. So we can say down or decreasing. And the end behavior is from quadrant 2 to quadrant 4. Okay, let's move on to the next one here. The leading coefficient, now it's written as, remember, y equals mx plus b. Remember that. This is your y-intercept. You tell it right away, and that's your slope. Slope is -4. But the sign of a leading coefficient is negative. So the negative in front here. And you could guess if it's negative, it's very similar to this. It's going down or decreasing. The end behavior should be quadrant 2, quadrant 4. Well, let's test it. We're going to go back to Desmos. So this is my equation here. I'll just put a little bit to my left. So y, I'm going to hide that one. To my next one here. Y equals -4x plus, now you can write 0.5 or 1 divided by 2. That's the beautiful thing about Desmos. 1 divided by 2. It gives you in the proper way to write a fraction rather than a slash. So if I zoom in here, I already pinched it. You notice the y-intercept is a half, right? So if you look at here, you have 1. This is your origin, 0. Go up by 1. So midway is a half. So if I tap on it twice, it tells me 0.5 in decimal. The slope is negative slope. So we can say that it's going down and it's from quadrant 2 to quadrant 4. You've done the same thing in the graphing calculator. For those of you who are, so first of all, we clear. Go back here, sorry, and you clear your y equal button and you input to your calculator negative. Now this one here, you have to be careful again. I'll just zoom out a little bit so you can see the keystrokes. Okay. Some of you will encounter some challenges. So negative, not the subtract sign. Slightly different from Desmos. Desmos allows you to use the subtract as a negative sign also, not the calculator. So you have to put a negative sign. Then it's 4x, 4. So it's your x button here. Plus, now what I would suggest is that you make this into a bracket, the half, or you can put 0.5. But let's put a half in there rather than 0.5. We can write 1 divided by, so open bracket, 1 divided by 2. So I would suggest whenever you have fraction, put them in a bracket on your graphing calculator. With Desmos, it doesn't really matter for most times. So now we do a graph, press the graph button. And there is our graph, very similar to what we have. Quadrant 2 to 4, and it's decreasing. Okay, let's move on to question 5. Now, question 5 has a whole series of fractions, and this is where I want you to be very careful with your graphing calculator, especially. So let's look this through. Notice we have brackets here. The leading coefficient here is positive. So we can write it here. Now the slope direction, if we looked at our previous question, whenever it's positive, it's going up, and it's quadrant 3 to quadrant 1. So let's write that down, and we're going to test our hypothesis, right? So the slope direction here would be up or increasing. and the end behavior is from quadrant 3 to quadrant 1. But let's see how correct we are. By the way, I'll come back and then we'll show you. Now, if you were to look at this question here, the y-intercept is not 3. Remember, we had the basic form of equation of a straight line. This is your y-intercept. But this is not written the same way. To write it in this form, I now have to, this is a common factor, multiply 2/3 times x and 2/3 times 3. So this will give me y is equal to 2/3 x plus 2/3 times 3 will give me 2. Because 3 times 3 over 1, which is 6 over 3, which is equal to 2. So this equation here is equal to y equals 2/3 x. I can't see here. 2/3 x plus 2. But be careful, this because it's 2/3 times x and 2/3 times 3. Give me plus 2 here. So now you can see your y-intercept is 2, your slope is 2/3. But let's go ahead and prove this here. Okay, I'll zoom out. Okay, center my camera. There we go. So I'll erase this from here. It looks kind of confusing. I'm going to remove this from here so you will not get too cluttered. Now let's go to our calculator. So to answer this equation, so I'll go back to my y equal button. I'll clear that line. Now, 2/3, remember I referred to as a bracket? Make sure you put this in a bracket. So if you were to write this out in your calculator, it will be 2, open bracket, 2 divided by 3 open bracket again, x plus 3. That's your graphing calculator. So let's do that right now. Open bracket, so it's your bracket symbol here. 2 divided by 3, close bracket. Another open bracket now. It's not given in the question, but you have to make that change in your calculator. X plus 3, close bracket, and graph. If you look back here, your y-intercept is 2, not 3, and it's exactly what you have here. Now, recall to find your y-intercept, use the second trace, and you touch the enter button, and you let x be 0, then y is 2. So here we have is positive, going up, and behavior from 3 to 1. With Desmos, we'll hide that. We'll go to the next cell. With Desmos, you can go on. We're going to hide that graph there. Okay, come on, disappear. We'll enter that equation, y equals. Now look what happened with Desmos. 2 divided by, automatically it makes into a fraction. So you don't need the brackets. Although you could, wouldn't hurt. Then in this case now, I have to move to my right now to get out of that fraction. Slight difference. Notice what I did here? So here I have the cursor flashing the fraction. Now if I continue, let's see what happens. It will put a bracket below it. So you don't want that. So you need to hit this right arrow key here so you can get out of the fraction. Then I'll put my bracket. And that's x plus 3. And close bracket. And there's your graph. Now, I can move this here so I can see my graph a little bit. So whenever your graph zoom in, you can also zoom out by pinching it. On your phone, now on your computer, you will have to use your mouse cursor to either scroll up, increase or decreasing on your mouse with your mouse. And there it is. So the y-intercept is 2, as we have here. Let's look at the next one here. We have, now this is, be careful. It's not written in the standard way. Okay. So here, the y-intercept now is to the left of the slope. But it doesn't matter, you can input this directly in your calculator and you'll have the same result. But if you're not happy seeing it this way, you can change it around because your y-intercept is the same as y is equal to negative 0.85 x plus 2. Remember there's a plus in front here. But we'll write it exactly as it appears in the question in our calculator. But let's look at this. The sign of a leading coefficient, you can see it's negative. So be careful with this. And if it's negative, we know what's happening. It's going down or decreasing. And the end behavior is going from quadrant 2 to quadrant 4. But we want to show that. So first of all, we go to our Desmos. And we hit this. By the way, when you see your full screen, right down at the bottom, there's a double arrow. Tap it. And you can clear all of these by hitting the X. You can clear that. Here we can go. If you want, get rid of it. And I can get rid of that. So you're left with line 1. Now we're going to enter exactly what we see here. We're not going to change it like this way. But we'll do both of them to show you it's the same. So y is equal to 2 minus 0.85 x, and there's your graph. Notice your y-intercept is plus 2. So this is your y-axis. Y-intercept plus 2. Tap on it twice, and it'll give you the y-intercept. Now you also tap on it twice to give you your x-intercept. The x-intercept is 2.3353, and y is 0. So standard of leading coefficient is negative. It's down in quadrant 2 to quadrant 4. Now with your calculator, graphing calculator, you can do the same thing. Let's move up a little bit here. I'll go to my y equal button first here, and I'll clear that data. Now I'll enter the equation as given. Which is y equals 2. Now, in this case, you don't have to use a negative, which is below here, negative sign. You can use a subtract sign. So that's a slight difference of what you were doing before. If it's a leading coefficient here in front of the x, the slope, then you'll have to use a negative at the bottom here. But because it is not the front here, leading one, you have to use a subtract sign. So 2 subtract 0.85x. So be careful on these, and then you press your graph button. Okay, which is the same as what we have here, right? Okay, so Desmos has a little bit more straightforward feature. Okay. Just for those of you with your graphing calculator, just to let you a warning of what happened. I mentioned in this case here, you have to use your subtract sign, or else and then you will get your graph. What happens if you use what we were doing before, this negative here? So look what happens, right? And this will indicate that you need to make a change, right? So that's what it's supposed to be. Let's assume now we put 2, instead of using this subtract sign here, we put a negative. Then we have 0.85 in our x. If we touch the graph button, we get a syntax error. Check all arguments entered plus the plus sign here for argument. So we're going to go to, and we need to change that. It's telling us, look, we need to change that symbol. So put a negative sign there. Now I'm going to remove this here because it's needed graph. There it is. With this calculator, the lines, different lines have different colors. And so if we were to write a negative now, we will not get that graph. So be careful about the signs here. So notice about it. So we have 2 final section of questions here to work through. And zoom in here. So y equal 5. Now this is a tricky one. We did a question that earlier, and it was example 2. So it depends on where you are. If it's negative, it's going from quadrant 3 to quadrant 4. If it's y is equal to a positive, so it's a horizontal line. There's no slope to this line. Therefore, it's a horizontal line. Whatever value for y is given, that's where it crosses the y-axis. That's your y-intercept, because the slope is 0. So it's either going from quadrant 3 to quadrant 4 or 2 to quadrant 1. So depending on where, if y equals 4 in this case, it will be up here. So it's from quadrant 2 to 1. Because it's negative, it's going from quadrant 3 to 4. So that's y is equal to 5. Now, for this one here, the leading coefficient doesn't exist, right? Because there's no slope here. The slope is 0. So no leading coefficient. So we have no leading coefficient. So that we say here, doesn't exist. Now the slope direction, right, as I mentioned before, going to be flat. But let's go to our calculator and see what it looks like. So go to my whiteboard button, and I'm going to clear the graph. Now I'm going to enter into my calculator my equation y equals 5. So I'll put 5 in there. Press graph. And there is your horizontal line going through y equals 5. So it's going from quadrant 2 to quadrant 1. So it's quadrant 2 to quadrant 1. So slope direction, we say horizontal. Flat. The end behavior now, it's from quadrant 2. Let's put it back here. Quadrant 2 to quadrant 4. Oh, sorry, quadrant 2 to quadrant 1. Let's go to quadrant 1 there. Okay, so there we go. The last question, 8, asks you to summarize what we've done so far. Which of the questions in number 1 to 8 are the form y equal mx plus b? Now, if we go to overall, remember y equal mx plus b are leading coefficient. And if you look at any of these, we have question 1 is like that, question 2 is like that. This is not. Question 4 is like it. This one is not either. So I'm going to erase this. So for this, so we can put here, so question 1, we have a question 2, question 3, not 4, yes. Anyone else? That's 5 no, 6 no, 7 no. So these are the 3 that are in the form y equals ax plus b or mx plus b. The next thing, if a is positive, if a positive number, what can you conclude about the graph? Well, if you look at all of these graphs here, when the a is positive, or the m is your slope. So when the slope, right, is positive, what you conclude? We can conclude that the quadrant is from quadrant, let's look at here. It's positive, quadrant 3 to 1. Positive, 3 to 1, 3 to 1. As if it's negative, it's not. So we can say if it's positive, it goes from quadrant 3 to quadrant 1, or we can say it's increasing. Or going up, right? Now, if A is negative, it's going from quadrant 2 to quadrant 4, and it's decreasing. So the graph is going downwards here. Graph is going downwards. Let's see. Let's go to the decimals here. So here we have a negative slope, so it's going down from quadrant 2 to quadrant 4. So let's recap. We set out to demonstrate the characteristics of a linear function. That was our goal today. The leading coefficient. We look at end behavior, We did not look at domain and range today. We look at the x-intercept, y-intercept. And we didn't look at the x-intercept per se now, and the end behavior. So we look at the end behavior. We know the slope, the leading coefficient. The next lesson, lesson 5, will be focusing a lot on the x and y-intercept and domain and range. So these are the 3.